afternoon, everyone. Our names are Ava, Elle, Sarah, Elizabeth, and Lucy, and we are the Trinity Turtles, team number 3. We're excited to present our 5-step plan for the University of Houston's Clear Lake campus. This plan is designed in order to repurpose unused spaces, manage stormwater, and make the campus more sustainable overall, all while creating opportunities for community and enriching student life.
Our first solution is seeking out low-impact development, or LID, on campus through green walls, rain gardens, and rainwater harvesting. According to the EPA, LID refers to systems and practices that use or mimic natural processes that result in the infiltration, evapotranspiration, or the use of stormwater in order to protect water quality. We would also like to emphasize that the first goal of any green infrastructure plan is to protect existing habitats. Therefore, we will respect existing jurisdiction on forested areas. With that being said, we have outlined some ways for the campus to develop in a manner that protects ecosystems and enhances the school's beauty. And green walls would be one line of defense against stormwater on the UHCL campus. According to a study done by a team at the University of Malaysia, a green wall using coconut peat is capable of absorbing 30% of runoff under very intense storm conditions. This would be a great benefit to the UHCL campus, considering that Houston is prone to flash flooding due to its proximity to the Gulf Coast. In fact, according to Move.org, Texas has lost over $45 billion in property damages to flash flooding alone. Additionally, UHCL is located in a low floodplain, making it especially susceptible to these threats.
Below the green walls and by housing would be rain gardens. Although they have been mentioned in the master plan, it is crucial for us to expand upon the existing gardens. These gardens would incorporate native vegetation, which would use little to no fertilizer. According to Texas A&M AgriLife, rain gardens are beneficial in reducing and slowing stormwater runoff, reducing pollution, and replenishing the groundwater supplies. In addition to aiding in Houston's flooding problems, green walls and rain gardens are aesthetically pleasing. As shown here, buildings that were once eyesores have turned into beautiful points of interest. This will attract students and Houstonians alike. Overall, rain gardens and green walls are an advantage to both the environment and the university as a whole. Additionally, rainwater collection bins will be placed in multiple locations on campus, as shown here. The water from these bins will not only reduce the amount of stormwater runoff, but they will also be used to water the prairies highlighted later in this presentation.
Further, green stormwater infrastructure, or infrastructure that reduces stormwater runoff, is rewarded by the City of Houston. According to the city, developments with a minimum of $3 million in investment that include at least $200,000 budgeted towards green stormwater infrastructure are eligible for a tax abatement for up to 10 years. This abatement could contribute to the funding of our project as a whole. As an additional incentive, the school could enter the EPA's Campus Rainworks Challenge, where student teams help design these green infrastructure plans. This would both involve students and the outline plan, and possibly help pay for it, for the winner is awarded a monetary prize. Our second solution revolves around the theme of student life. UHCL currently hosts about 9,000 students, but has a long-term goal of being able to host 15,000. To do this, the university has a few plans already in place. These plans include expanding current parking spaces to accommodate 5,100 spaces and expanding current housing to accommodate 3,000 beds. This is all being done in an effort to become a more traditional four-year campus. However, the university wants to place an emphasis on expanding in a sustainable way. We offer a few ways to do this.
First, the university has a plan to build 2 four-story parking garages on campus. We estimate that this will cost about $40,635,000 and would add 1,890 spots. To pay for this, the university will likely charge for parking and manage to pay off the cost in about 8 to 10 years. This is pretty standard, but what does it have to do with sustainability? There are a few ways we can make this structure more sustainable. Firstly, we plan to install solar panels on the garage, which I will expand on in a moment. And secondly, we plan to add vertical gardens or green walls to each of the new buildings we construct using the methods that Elizabeth discussed earlier. Second, utilizing solar panels in a few unique ways. Firstly, we plan to build solar panels over the existing and new parking lots in order to redirect stormwater runoff away from the parking lot and towards the green walls. This is easier to do on garages because the water has a direct place to run off. But for parking lots, which hold about 3,000 of the current parking spots, we plan to direct the runoff towards pervious pavement areas and green spaces within the lots and build solar panels that cover about half of each parking lot. Pervious pavement between the parking lines can minimize flooding in the parking lot and add a bit of green space to the parking area, maximizing both aesthetics and carbon reduction.
We also plan to use solar panels to increase energy efficiency. We intend to build 3,025 panels to cover 16,640 feet of parking space. This endeavor will cost us around $3,697,105 in total, which would be paid off over the course of 10 years. Photovoltaic panels can be installed on roofs, in ground arrays, or as parking shade structures. Local energy companies, research partners, and grants can help to implement this technology, but we intend to use a combination of these grants and budget to pay for the panels, including, as Elle mentioned, tax abatements from the City of Houston, as this project costs over $3 million. While this sounds like a scary amount of money to spend up front, UHCL will actually manage to save money in the long run. Our solar panel plan would produce 75,625 kilowatts of energy, which is a lot. By creating so much energy, the university can save a lot of money. Currently, the cost is $1.1 million, but with solar panels, it would only be $8,318.75. Depending on just how much energy the university saves, exactly, we estimate a saving about several $100,000.
And the last factor of student life is housing. The university wants to add beds and create a more connected feeling between the two sides of campus. We believe that there are two sustainable ways to accomplish these goals. First, transportation. The best way to connect the campus is by extending the nature trails across the bayou and creating a reliable shuttle service as mentioned in the master plan. Ideally, the shuttle service would consist of electric or hybrid shuttles. Nature trails will not only allow for more biodiversity and wildlife to be able to thrive, but will also provide recreation and green spaces for students, something that was mentioned as very desirable. In terms of housing, the university plans to build several dorms in 2 locations. We plan to add a couple of things on these dorms that will be beneficial to the students and the environment. First thing is the addition of greenhouses on the top level of the dorms, which will provide additional sustainable sources of fresh food on campus and also help catch rainwater. We also plan to add our green walls plan onto the sides of the dorms, both for stormwater retention and aesthetics. Lastly, we plan to add green space around the new buildings, which will serve as recreation and habitat corridors for wildlife.
Our third proposition includes restoring a strip of prairie land to function as a sort of buffer zone to absorb stormwater runoff from the campus and minimize the amount of runoff into the floodplain. As you can see from the photo, the land above the pipelines creates a harsh edge effect with the forest southwest of the campus. It stretches approximately 2,000 by 250 feet, and we've circled this area in question in white on top of the map on campus. These harsh ecological transitions eliminate ecotones and reduce biodiversity of the area by increasing exposure to noise, light, human interference, and pollution. To mitigate these effects, as well as increase plant and animal life in this relatively empty strip of land, we propose restoring this area into a prairie ecosystem.
And prairie lands, even relatively small strips of the ecosystem like we suggest, could provide critical support in managing stormwater and mitigating the harmful effects of runoff, as well as boosting the biodiversity and aesthetic value of the UHCL campus and community. According to the Native Prairies Association of Texas, a high-quality prairie can support hundreds of plant species, meaning that on a smaller scale, it can maintain more species diversity than a rainforest. This heavy plant diversity provides critical habitats for pollinators like monarch butterflies and bees, whose populations are declining. Perhaps most importantly, though, the deep fibrous roots of native grassland plants increase water infiltration, which in turn slows down and absorbs floodwater. Even with the low-impact development strategies we highlighted earlier in this presentation, any expansion undertaken by the university is going to increase impervious surfaces and risks heightening levels of contaminated runoff from the campus entering the floodplain and contaminating the water table. Because of their natural filtration properties, prairie ecosystems could serve as a pollution buffer to minimize the amount of pollutants that enter the campus's surrounding ecosystems. According to Dr. Lisa Moore, Associate Director of the Bioeconomy Institute at Iowa State University, in addition to attracting pollinators, strips of prairie ecosystems have the potential to reduce phosphorus runoff by 77% and reduce overall nitrogen loss by 70%. This means that the prairie zone would be a means of filtering out any pollutants from potential chemical fertilizers used in the UHCL community.
The roots also secure soil and help prevent erosion and sedimentation, which would additionally increase the water quality of the surrounding river and wetland ecosystem by preventing soil contamination in the water, in turn increasing water clarity, decreasing turbidity, and increasing the amount of light that can filter through the water to support aquatic plant life.
Additionally, the cost of incorporating this prairie strip is relatively low compared to the ecological services it would provide for the campus. According to the Iowa State University's research, the cost of maintaining a strip of prairie land costs on average less than $300 per acre annually, with initial costs ranging from anywhere from $1,000 to $2,000 per acre.
In addition to this main strip of restored prairie land, we would also like to incorporate smaller bands of native prairie plants in the northern point of the campus as indicated on this map. According to the university's master plan for developments, this area is projected to be converted from a forested area to a space for recreational sports activities. The additional courts that the university intends to construct, while they would increase the campus's recreational capacity, would also create more impervious surfaces in an area that used to be open soil. To contend with this, we propose creating vegetative borders of native prairie grasses and flowers around the courts. These are some examples used in residential areas that we think illustrate this concept well. While these mini prairie strips would help to catch rainwater and reduce runoff, they would also increase the aesthetics of the area. Additionally, they'd emphasize UHCL's commitment to sustainability and pride in natural habitats by promoting efforts of natural beauty and maintaining biodiversity, even in areas that had to be cleared for the campus's expansion.
UHCL's commitment to natural habitats shouldn't stop with their prairies. This campus is a unique opportunity to create a rare ecosystem that is often overlooked as an area just asking for bug infestation. The EPA describes wetlands as biological supermarkets, not just because they produce great quantities of food and provide a habitat for a variety of species, but also because they store lots of carbon within their plant matter that is preserved instead of being released into the atmosphere, which could negatively affect global climates. The benefit of wetlands is also economic, as these areas can act as floodplains, deterring potential flooding and saving landowners thousands in damages. The EPA also presents that nature-related recreation is the fastest growing activity of the tourism industry, with an annual increase of approximately 30% since 1987.
Students at UHCL are also intrigued by these outdoor spaces, as shown through the My UHCL survey results. Students were especially partial to bike trails and gardens, both of which we have highlighted in our plan for reconstructing this campus and can be integrated into our plan for the campus wetlands. Now, the actions proposed in the master plan regarding the wetland were to create a larger wetland area named the Wetland Garden, which mitigated the habitat fragmentation present on this campus and provided recreational possibilities for students. This is essentially what we propose should be done with the campus. However, we propose that more emphasis should be placed on the garden aspect of this plan, rather than completely reconstructing the wetland, which could unintentionally release the aforementioned preserved carbon and could permanently damage this vital ecosystem.
We conducted an interview with an employee of the American Rivers Organization regarding our plan and the construction of wetlands, and he proposed that it was impractical to expand them and that we should instead focus more on connecting them with ponds and vegetation. We tend to take this advice and focus more on creating vegetative spaces that can absorb and slow down prospective runoff, prevent flooding, as well as create corridors between the surrounding forest, Potter Pond, and the Palestine wetland. According to a study done in Iowa by Tyndale and Bowman in 2016, wetland plants and the price to plant them are on average about $640 per square acre. We calculated that there are at least 5 acres that we would want to develop in this manner, and that 100 to 150 plants per acre would be enough to replicate wetland vegetation conditions without having to completely empty and refill this ecosystem. This could be paid for through the extra profit gathered from the introduction of solar panels on campus, or through a grant such as the North American Wetlands Conservation Act Standard Grant, which is offered by the U.S. Fish and Wildlife Service.
In addition to any vegetation specifically recommended by the planner's task with remediating the site, we recommend a few native wetland plants for this area, prioritizing aesthetic value, water consumption, and benefits to the present ecosystem. None of these plants present threaten the overall overconsumption and can thrive in a variety of soils and water quantities. The button bush, shown here, is an intriguing plant that can live directly in water, moist sites, or even just regular garden soil, making it a potential species for the flood zones present on campus. The Torrenia is partial to shaded areas, which could make it a good flower for parking lots or near buildings being shaded by the solar panels. However, it can also live directly in water and could even be placed in floodplains and wetlands like those near Bayou Crossing. The other 2 plants shown here, the southern wax myrtle and the Louisiana iris, are also water-loving plants that could survive in these unique conditions.
The ultimate benefit of these wetlands is their mitigation of a few of the campus's most pressing issues: habitat fragmentation, a lack of plant biodiversity, and prospective channeling of stormwater. This new ecosystem would connect these smaller wetland areas back to the surrounding forest, providing these species with a source of drinking water, and preventing them from being trapped in the anthropogenic areas, such as with the ever-present deer on campus. Planting and supporting new wetland species that won't outcompete the originals would help increase this campus's plant diversity, which would ultimately benefit the surrounding ecosystem and soil quality. Finally, the use of wetland vegetation would address channeling, as the institution of these species could slow down rushing waters and sift through sediments floating through them, reducing erosion.
In the master plan proposed in November of 2017, there's a specific basin that was designated to serve as a soccer field. That use has its pros and cons. While that use encourages students to use the space recreationally, transforming the area into a park would also have incredible mental and physical health benefits for the students, as well as preserving the vegetation and environmental integrity of the campus. Let me first discuss the mental health benefits of transforming the area into a park. In one study, cognitive functioning was improved in those who were exposed to a natural environment. Experiments proved that a natural park-like setting improved working memory, cognitive flexibility, and attention control, not to mention the impact it has on reducing depression. There's even a form of therapy known as ecotherapy that treats moderate depression. This park is certain to improve the mental functioning and state of those on campus. Students and others in the community will have the opportunity to educate themselves as well.
And in the Texas A&M AgriLife Center in Dallas, Texas, we can see examples of signs that give the viewer information on the varying species of birds, plants, and other local flora and fauna. These encourage residents to come and visit the campus and to take an interest in preserving the natural environment.
We also have a unique opportunity to repurpose those stadium lights into bat houses for local bat species in the area. It's mentioned in the current state of the campus that these lights haven't been utilized, and although they have the potential to be used if the space was utilized as a soccer field, this use benefits the local wildlife. These light posts provide a fantastic opportunity to maintain pests and increase natural biodiversity. These tall poles mimic the environment where bats usually create their nests and are often preferred to trees, since flying through thick branches can often result in injury, as these bats rely exclusively on echolocation to see. The cost of making these houses is on average between $10 to $20. The cost for equipment can reach up to around $250. However, these are things that can likely be found on campus, such as saws and mechanical machinery. However, these costs are easily paid off by donations or from the agricultural value of insect control that these bats provide. According to the Texas Parks and Wildlife Department, studies have shown that the agricultural value of insect control from bats is $1.4 billion annually in Texas alone. These species also serve as crucial pollinators and can serve as a vital method of student engagement with the campus. We could establish small cameras in order to live stream the lives of the bats within these houses, which could be viewable via live stream on the campus website or through the environmental center near the basin. A club could also be created in order to continue the maintenance of these houses and to collect donations and provide education on what exactly they are doing within them. All in all, these bat houses provide an opportunity for students to get involved in campus life and provide an academic opportunity to have an outdoor lab through which students can learn more about small ways students can protect Texas wildlife on campus or at home.
This park would also be incredibly environmentally conscious and would be a step the university could take in a more sustainable direction, rather than a soccer field. The native vegetation, once implemented, would provide a protective barrier against erosion and would help regulate the water cycle of the campus, providing a permeable surface for water to drain through. Because the vegetation is well suited for the area, it provides a perfect environment for various local animals. This basin provides an incredible opportunity to build something that will make your campus stand out. This park has the potential to become a center for community life, for people to come relax, study, and rejuvenate themselves. Walking trails could also be built through the basin to encourage students to visit the various nature sites.
And so we just want to thank you so much for your time and for listening to our 5-step proposals today. We hope that our plan, which involves low impact development, habitat corridors, the creation of a park, incorporating student life, and the formation of buffer zones, will help the campus with stormwater management and sustainable expansion. We appreciate you all for your consideration, and thank you.
Well, thank you. Thank you. That was very, very interesting and beautiful slide. Really learned a lot. I took lots and lots of notes. We have some time for questions. Do members of the judging panel have questions for the team?
Yes, I would like to ask a question. First of all, thank you. That was a really interesting presentation. There were things in there I had never even thought about. I wanted to ask a question about the green wall. You mentioned that coconut peat would be used for planting the green wall, and I was wondering how you arrived at that decision to use that, if there are other choices or if there's a benefit to using the coconut.
Yeah, so we looked into all the different options that were given. And there was a large list we were giving. We looked into research on multiple of them, but the University of Malaysia team did some extensive research on coconut peat, and it's really sustainable to come across because it like reuses coconuts, the parts that aren't used in our of them. So it's kind of like the most sustainable overall, not just with absorbing stormwater. We wanted to make sure that was a priority.
And it's also really good in absorbing like high amounts of rainwater. And that's also a priority because it is so flood prone.
Yes, and
there
we
are a lot of
did
heavy rains.
actually get for the intense, we said intense storm conditions.
It was about 30%.
Yeah,
total.
and so it gets, that's 45 milliliters in 15 minutes is that storm condition. So those are really like heavy rains, which Houston does get. So we wanted to focus on that as well.
Indeed we do. And I have a follow-up question to that. Is there any concern about damage to the buildings when you put up a green wall, or is there some preparation that has to be done?
So it's pretty good for the buildings. The biggest thing is choosing plants that are like grasses, more lightweight type plants that aren't going to bring down the structures existing, but you do need to like inspect the walls and their sturdiness beforehand, but it is a relatively common and easy process to go through. We have a lot of them around here too, which are really cool.
All right, thank you very much.
Of course.
I also had a follow-up question. The note that I made in my notes was actually about the same thing. And the question I had is, because I love this idea of green walls, but I also had that question about coconut peat. And Malaysia has a lot of coconuts. However, South Houston does not. And so in terms of a sustainable choice of material, I was wondering if you guys looked into something else that would be local, that we could source locally. So, because if we're going to have to transport coconut peat, it's going to have to come from somewhere else. We are not very heavy in coconuts around here. So just asked if you had some other concepts that might be better, reduce those transportation costs, reduce the energy for transportation, all of that.
So we could be looking into some peat moss, which is a little more common around here. We could also use compost manure for these green walls, and like incorporate those two. There's and we can put in a mix of like the peat and the organic matter, and that would actually help around in the surrounding areas. If there's farmland, we could take some of their manure and incorporate that into making our vegetation more vibrant, and it helps the local economy as well.
Yeah, peat moss is an incredible. Sorry, there's echo in here. It's an incredible retention material. It absorbs tons of water. Like, it has a lot of uses, especially in like household green walls and smaller green walls. And I think because it's more common here, especially, this is definitely something that we could take and use in a larger form, which, I mean, coconut fiber might be a little harder to come by, obviously, since we're not in Malaysia, but peat moss is definitely a good replacement for that, since it's kind of comparable to what they have there, since it's much more common to us, like coconut fiber.
I just wanted to say, I really enjoyed that. I liked your focus on the cost and possible funding. I thought that was a really nice angle to take. You stopped sharing so quickly. I think the last slide may have had your references. I didn't know if maybe you could share that again so that we could see that.
Let me share this.
We actually have 4 pages of bibliography, 4 slides.
I'll go ahead and we can leave them up.
While we're looking at that, I have a question. I was intrigued by your notion of using bat houses, converting lighting to bat houses. I do volunteer work in a park where we've installed bat houses, and we've run into difficulties of trying to match the right kind of bat house to the specific environment in which we've placed them. Did you find any information about how to choose particular kinds of structures, or how to match a structure to a specific environment?
Like matching them to specific bats or specific environments, or?
Well, more specific environments, so that when you put in bat houses on this specific campus, that is a type of structure that would work well there. I'm just curious, and really I'm curious as much for myself. It seems to be kind of a challenging aspect of this. How do you find that right structure that will attract the bats?
Yeah, so bats usually prefer smaller areas, which is really cost effective. Like they don't like tons and tons of space in those houses because it feels very open and it's kind of like dangerous in their natural environment to have too much space. So using those small up on high areas like those poles would be perfect because they're just super high up in the air. There's not many trees around. And a big issue that we found while we were researching was that bats in the area actually had issues with nesting in certain trees because echolocation was their only source of vision. So, I mean, it was really difficult for them sometimes to get around whenever their nests were put in places where there was lots of branches and that there was a lot of vegetation that was covering their ability to fly elsewhere. So I feel like these large poles in an area where there really isn't any large vegetation and in a couple meters length would be a perfect way to add these houses in an area that like they're going to benefit from, not just where the students are going to benefit from, which is easy to do because we're all like, we want to see them. We don't care what the bats do. We want to see them. We want to see what the bats look like. But this is a good way to compromise the bats' well-being as well as the student well-being because both benefit.
I would love to expand on that as well. So these stadium light poles really provide just the perfect opportunity for these bats to find a home because of their height and because of the fact that there's no vegetation around them. The bats who rely on echolocation to see really have the opportunity to create like a little nesting site in there because of the lack of vegetation and the abundance of light.
Very good. Thank you.
I have an additional question, and I was thinking about, and again, I want to echo Dr. Kelling's comments. I really enjoyed your presentation. I also really appreciated the inclusion of the different funding sources that might be a source for money to do some of these things. My question was on the prairie restoration that you proposed for the utility corridor. And the utility corridor, which and while I really love the concept, that utility corridor, I mean, at the moment it is covered in construction equipment. They're putting in 2 pipelines there. And it is something which basically we on campus don't have any control over. So my question to you would be, how might you approach approaching the owners of those utilities in terms of trying to get them to come around to this idea?
Well, first of all, I think one appeal of it is that it is a pretty fast moving process. So for there to be like a full prairie ecosystem, it's about 5 to 7 years, which in the grand scheme of things isn't much. So even though now it's really covered in construction material, once it was actually renovated, it would be able to give back to the natural environment really quickly. But as far as approaching the people in the community that would allow us to do this once the pipelines were installed, I think just based on the pure aesthetic value alone would be a very good talking point. I don't think anyone I've ever met likes having a empty like dirt lot with construction tubs in their backyard. So just emphasizing how prairies were such a huge part of the Houston culture and environment before, especially when Houston was being established historically, the ability to do it was based on the rich soil. So it really is returning to that culture.
I also want to add to that we can also bring in the point that it'll reduce stress on their pipelines and such by reducing the stormwater runoff on campus. The drainage systems on campus will not be as overwhelmed. So ultimately these utilities will benefit from having prairies on campus.
Well, thank you all very, very much.
Thank you.
Thank
Really
you.
Thank you. We really
Thank you so
appreciate it.
much.
This was an unbelievable presentation. You guys did an amazing job. Just wanted to put
Good
Thank
luck.
you so much.
Thank you.
that you guys should definitely continue to pursue.
Thank you so much.
Thank you.
Yep, you guys are great.
Bye.